let's continue and finish our tactical design using test-driven development in this part. So we come quite a long way. So what we did was we created all these tests. We wrote the code to implement some of these features. So at this point in our tic-tac-toe, we are able to place a peg, we are able to place a second peg, we are able to verify that the peg placed was the right peg. We are also able to verify that we cannot place a peg on top of a peg that is already there. It simply ignores and returns whatever was there already. So we've done all of that. Let's get to a few other details to wrap this up. The next test that I can think of is win by row match, and then win by column match, and then we could also think about win by a left diagonal match, and then finally win by right diagonal match. So these are the four tests that I can think of. But also, while thinking about it, once we win the game, what happens if somebody tries to place a peg? So place peg after a game is won. And that's a condition we want to think about as well. Well, we're going to start with the win by row match. But what does it mean, win by row match? When a particular peg has been placed, potentially there could be a winner. There could be a winner according to a row or to a column or diagonally. So we need to detect whether there is a win, and then we also need to tell who the winner is. So there are two parts to this. It's better to really break it down into two parts. The is winner or winner function, which tells us who the winner is going to report somebody who has won the game. But that reporting only has to happen if there has been a row match, for example. So we could break that into two. So win by row match, and then we could say declare winner, let's say for row match. So let's start with this. Likewise, we would have a declare winner for column match as well. And then, of course, we would have a declare winner for a diagonal match that has to come in. And of course, this could be for either one of them. Doesn't matter. So let's start with win by row match first of all. So how do we provide the win by row match? Let's write a test for that first of all. So we will say here win by row match. And all we care about here is whether there has been a winner or not when a peg has been placed. That's all we care about. So to do this, there are a couple of different options available for us. We could place the pegs using the place peg methods, and then we could check for a winner. Alternately, we could also manipulate the collection directly and then look for a winner. Now, which one is a better idea? Should we keep calling place peg several times, or should we reach into the cells and directly manipulate it? There is no real good answer in this area. Sometimes I do one way, sometimes I do the other way. I don't want to go through a series of calls to set up a state. I might readily inject a state and be done with it. That's one option. The other option, of course, is to really call these methods. Let's examine both ways, but using two different examples here. So let's go ahead and set a row match scenario. So tic-tac-toe dot place peg, let's say 0, 1 for a minute. Now let's go ahead and copy this a few times over. So 0, 1, 0, 0, and 0, 2. So those are the alternate values. This guy is going to be all over the map in 1, 1, and 2, 1. So remember, this is going to be the first, second, first, second, first. So this has been the first row in this particular case for us to be able to handle this. Now at this point, we can simply say assert equals or assert true, and we will simply say tic-tac-toe dot, we will call it as is row win, or is row win, or is row match. So let's go ahead and say is a row match. So I want to implement is a row match. What should I do within this? Obviously you want this to be a win, so can simply say true here and be done with it. So in this case, if we go back and run these tests, you can see the test is actually passing. But we didn't really write any useful code at this point, but we got this one test passing. We could simply write another test, win by second row match or a third row match, for example. So that will force us to write some test at this point to get this moving. Or we could set up a scenario where there is no row match. How about that? So let's say no win by row match. How about that? So if I write a no win by row match, that obviously has got to do some work for us to set it up in the condition where it doesn't work. So let's go ahead and say no win by row match. So this is going to be win by row match, and this is going to be no win by row match. So what am I going to do in this case? Well, we placed only these pegs so far. We placed a first, a second, a first, a second. So this should definitely be a false because there is not a win at this time. So go ahead and run this little code and see what it tells us. Well, obviously I need to import that. Let's go ahead and import that. And what does it tell us now? Well, we returned a true, obviously, so this is going to fail. And it tells us the test is failing because it expected a false, but it got a true. So to fix this, let's go back to the code. We need to really implement some valid logic here. So the logic we're going to implement here is we're going to simply say, go through the sequence and look for a match where each of these are matching to the same peg. So we're going to say at this point, if, so for example, for a row to the size itself that we have, whatever the size is, so we'll put the size. So this is going to be a row. So let's go ahead and try to write this. If the pegs are the cells at, well, the value I and 0 is equal to the cells at the value I and 1, and the cells at 1, obviously, that is the second cell, so we'll say I and 1, is also equal to cells at I and 2. Well, if those two are matching, we can say return true right away. And if it is not matching, we will return a false in the very end. So we are saying if these cells match with the cell next to it and the next cell matches with the one next to it, then return a true, otherwise return a false. But of course, we also know that the cells could be none to begin with. So we need to also add one more condition where it says cells at I and 0 is not equal to peg dot none. We are only interested in these other two pegs we are concerned about. So now if we go back and run these tests, we can see that the test is passing, and that forced us to implement a little bit of a logic here to get that working. So we implemented that particular test as we can see right here. Then the second thing is declare winner for row match. Now we need to know who actually won the game, so that is something we need to determine. So let's go ahead and write a test for that. So this is going to be a test that says let's say first player is winner on row match. So how does that really work? Let's set up a scenario here real quick, and then we'll come back and discuss about it. Let's grab this part for a minute. If you look at this sequence that we have without the last call right here, so let's remove this last piece right here, but keep everything else that we have until this point. So if you get rid of this for a second, what does this do? First, second, first, second, first, but who is the winner in this case? The first is obviously the winner in this particular case. Well, how do we know who the winner is at this particular point? When we place this peg, the current peg will be second. When we place this, the current peg would be first. When we place this, the current peg will be second, first, second. So once a peg has been placed, the winner, if there is a win, the winner is going to be whatever peg that matches it, right? So in other words, if you place a peg, if you place 3 X's in a row, you win. If you place 3 O's in a row, you win, or whatever the first player and the second player. However, in this particular nature of this game, the person placing the peg obviously wins because you are determining if there's a win or not every time a peg is placed. So whoever doesn't have the current peg is going to be the winner. If one placed it, the current peg is going to be true. If there's a win, it is 1. If the current player is 2, the one that plays last is the second player. Sorry, if the current peg is 1, the first player, then the one that got placed is the second player. And if there's a win, it will be the second player. That's one way to approach. Another way to approach would be to simply return the peg that came out of this. And we could simply ask, what's that peg? So if there was a match, we could return from here the peg that was matching. And if there was no match, we could simply return whatever that was. In fact, I like that idea a little bit better. So let's go ahead and refactor this test to do that. So rather than a true or false, what we're going to do is we're going to say win row match. And this is going to be assert equals. And in this case, we're going to say peg dot first. And then we want the tic-tac-toe is a row match. And so similarly, this one, rather than being false, would be equals. But this time around, it'll be peg dot none to say that it is a none that was received. So now we can go back to this code and we can simply say this is going to return a peg. And in this case, it'll be peg dot none that it's returning, whereas this will be whatever that peg is. So that'll be cell I and 0, for example. That's what we're going to return from here. So again, we made a significant change here. We want to make sure that the refactoring worked properly. And sure enough, the test is passing. So that tells us life is good. Now that brings up to the point of the last test that we are writing. So we placed a peg. Who should be the winner in this case? Well, in this particular case, the overall declaring the winner should be whoever placed that peg. So first, second, first, second, first. In this case, of course, the first is winning. So what does that mean? We want assert equals peg dot first, and then we want this to be really on the tic-tac-toe dot. And remember that good old winner function that we wrote quite a while back. So we are calling the winner function and asking, what do you want to return? Let's take a look at the winner function. Oh dear, notice it's returning string. That's all we knew at the time, but we know better right now. So we're going to change this to return a peg, and this can be peg dot none as the default value, which means, let's go back to the older test we wrote, which is going to be this guy here, and he's complaining already. So that's going to be really returning a peg dot none rather than a word none itself. So that brings up to this particular point, is this going to work? So if you run this test, you will see that this last test is failing because it's expecting a first, but what it's returning is a none. And you can see where that failure comes from, and you can click on that link, and that's the last one we wrote. But before we try to fix it, let's think about the solution for a minute and see if we can write the test in a slightly better way. Well, if you really look at this, the winner, what is that going to do? The winner needs to check for row, column, and diagonal match. That's essentially what it's going to do. But I don't want to be setting up these scenarios over and over and over. The logic in the winner is rather very, very simple. The logic in the winner simply says, if get is a row match returns a match, I'm going to simply return it. That is all it cares about, right? If there's a row match, I'm going to return it. If there is a column match, I'm going to return it. If it's a diagonal match, I'm going to return it. So in a sense, the code we're going to write in the winner is, it's going to check if any of these are returning something other than none. And if they are returning something other than none, it's going to return that. So if that is the case, we don't really need to do the real work to make this work. All we need to do is simply tell what to return and have that do its job. So in other words, all we really care to do in this case is, rather than going through the sequence, let's simply hijack the is a row match function and tell it to return something that is meaningful for the result. So let's change the test a little bit. So let's go ahead and say that winner reports a row match. Let's say winner reports row match. Well, how does that work? We're going to say here, let's go ahead and say tic-tac-toe equals new tic-tac-toe. Notice I am creating an anonymous inner class, and I'm going to override the is row match function. And here I'm going to return, just for an example, let's say peg dot second, for example. Now I'm going to simply say this is going to be second as well, that the winner is reporting. If I run the test this time, you can see that this pretty much fails because the code is still returning the none. So to fix that, we are going to say if, so first of all, peg winner equals, and we're going to say in this case is a row match. If the winner is not equal to, well, actually it doesn't matter. We're going to simply return the winner as reported by is a row match. Let's see what's going to happen. If I go back and run this code now, you can see that the test is passing. And again, let's revisit what we just did here. In implementing the winner, we did not have to go through the entire sequence, because the winner is an upper level function that depends on a lower level function. The upper level function is relying on the low level function. If the low level function works properly, all we care about is the higher level function is properly using the lower level function. We don't have to worry about the lower level function working properly because another test or a couple of tests take care of that. Given that the low level function is working properly, we only care about what the higher level function does with the low level function. It may get a little bit more clearer when we try out a couple of more examples here. So let's go back to win by column match. So to implement win by column match, let's go back to this example scenario here. Once again, I want to do two tests over here for win by column match. So let's go back here and write win by column match. We'll come back and fix that in a second. And let's start with that first. We should not be in a hurry to write this. We'll come back to that. So a column match, how do we do this? Let's make the second guy win at this time. So we're going to say second, and this is going to be win is a column match. So how do we do a column match? Well, to do a column match, what we're going to do here is we're going to first of all say the first player places at 0, 1. The second player places at 1, 1. The first player again places at 0, 0. Well, actually, let's change this a little bit. Let's go to 0, 2. And the first player is going to place at 2 and 2. So 0, 2 and 2, 2. Whereas the second player places at 1, 1 and also at 0, 1, let's say. So that is 0, 2 and then 0, 1. And the first player again is going to place it at 0, 0. And now we are going to place one more time, but this time this guy places that over at 2 and 1. Let's make sure this is correct. So this one, it may help to put a little piece of paper and draw on it. So 0, 0, 0, 2 is the last one, and 1, 1 is the middle, and then 2, 2 is again the last one, and 0, 1 is the one above the center one. 0, 0 is this, and then 2, 1 is the middle one. So we have a column match, and that should be a second player matching the column. So let's go ahead and implement this code. Here is the column match, and all I'm going to do is return a true. That is, I'll actually in this case, remember, we are going to return a peg. So this is going to be our equals. So we simply have to return, well, the reason it puts a Boolean is by Java convention, is means it's going to be a Boolean. We'll fix that in a second. So peg dot, we're going to return a peg, and this is going to be peg dot second. That's what we want to return. Let's make sure this test passes before we do the refactoring. The test is passing. Let's go back and fix that little problem. Rather than calling is row match, we will say check row match. How about that? So refactor that little method call. So where is that? Right here. So that's going to be check row match. That's going to refactor everywhere that function is being used. Again, Shift F6 is going to be check column match. And let's go ahead and run the test to make sure the tests are passing. So fire it up, and we can see in this case the test is actually passing. Well, that gives us the value which is a second. That's what we just returned abruptly, but we need some real code in there. So to get a real code in there, let's go ahead and copy this over and paste this here. Change this to no win. So we have no winner on this. and we remove very last one, and this better be none. Once again, let's go ahead and write this code, run this test. Now let's go back here and say, well, check column match. What do we do? Well, obviously in this case, we're going to return a none in the very end, but we're going to say iterate for j is going to be in the size that we have, and we can simply say in this case, very similar to what we wrote here. So let's bring this over and change it to if it is a 0 and j, and if this is a 1 and j, and likewise this is going to be a 1 and j, and this is going to be, of course, 2 and j, and then finally we're going to say here is going to be 0 and j. Those are the values we are interested in checking. Then we finally return 0 and j from this. So now if we go back and run this code, we can see what the result is going to be here, and we can see the test is actually passing. That's because we are returning the proper result based on the fact that there is no match. Likewise, we can now implement our next test, which is declaring the winner by column match. We're going to apply a very similar trick as we did before with just a little bit of a twist. So let's go ahead and say winner reports row match. Let's do it for column match. So what are we going to do in the case of column match? We're going to say winner reports column match, but in this case, we're going to override the check row match and return a none. And we're also going to override the check column match, but this time return, let's say, peg.first. Now, if we go back here, we're going to ask for first to be the winner being reported. Let's go ahead and run this code and see what it does. It fails because it expected a first, but none was being returned. The failure was obviously in the test we just wrote, and we know the reason for the failure. We never really used the column match check. Now what do? Well, we can now say get the winner, and if the winner is equal to, not equal to, we could say peg.none, then we want to return the winner already. Otherwise, we can say winner is equal to check column match. And then in this case, we can return the winner that the column match actually provides. So we can now go back and run the test to see what the test does. And let's see what it wants to report. It reports a pass, but we can now come back, revisit, and see if we want to refactor this code. So what is going on here? If any of them return a winner, we want to return that winner. But if all of them return a none, we want to simply return a none. So how could we refactor that code to say that that's what we are expecting? Well, we could call if check row match is equal to none, and then we can check if check match is equal to column match is going to return. But unfortunately though, if one of them returns something other than none, we need to know what was returned, and we should be able to return it. So we could come up with other interesting ways to refactor this code. And then if we refactor the code, we can run the test to make sure that the test is still passing. And then, of course, if the test doesn't pass, our refactoring is not correct. We can come back and fix the code. So we can improve this code once the test is passing. We could certainly do that. So we got those tests passing, and likewise we can implement the test for diagonal match as well, and then of course we can check for that. And finally we could write a test for place a peg after a game is won, and for that of course we could say once a winner has been declared, we should not allow for the pegs to be placed, and of course the logic for that would be in the place peg we could check if there's a winner. If it is not a none, we could allow it, otherwise we could ignore or throw an exception, whatever we decide. But I'm going to leave that feature unimplemented so that we can move on. We're not going to learn anything more in this approach by implementing those a few more tests. Let's revisit the things we talked about. We looked at quite a number of practices so far that we want to follow. We also looked at a few principles here. We also looked at one other principle here as we wrote it. Remember, we moved the toggle function. That brings up one more function, which is SRP, or single responsibility principle. It also comes to another principle as well, which is called the SLAP principle, which stands for single level of abstraction principle. So when we wrote the toggle function, let's revisit that to understand what we are talking about. If you look at the toggle function we wrote, let's go back and look at the toggle. We were in the place peg, and we said we're going to call the toggle rather than doing this work, and that really kept the focus of this function to just placing the peg and let the toggle deal with its own responsibility. And also this separates the abstraction level where we are making an if-else statement decision into a lower level of abstraction, so that code is a lot more easier to understand and easier to read. So we saw the ways of developing test cases. We can put a UI on top of this fairly easily now if we choose to do that. For example, let's say how we're going to do this. We can create over here yet another source code here. Right here we could create a UI, for example. So let's say in here we are going to create another package, if you will. And the package we're going to create here is called, let's say, game.ui. And within the game UI, we could create another class, and we will call this class as tic-tac-toe, let's say, frame. So now that we have a frame on our hand, what do we want to do with it? Well, depending on the tool, if you're developing a web-based application, you could start writing tests at the UI level. For cases like this, you can still write test by reaching into JFrame and try to write test on it. I normally keep these tests very, very limited, or even a manual testing is okay if you're going to keep that very minimum and all the logic in the lower level. But if you have a way to write a tool, use a tool to do this testing, I encourage you to do, because you can then get an automated feedback loop. It's a little bit harder with the desktop UI compared to web UI in general. So what do I want to do in this particular case? Well, I want to extend this from JFrame. Let's start with that. I'm going to write a public static void main method. In this case, I'm going to say JFrame. We'll say frame equals new tic-tac-toe frame. And let's go ahead and say frame.setSize. And let's go ahead and set the size of the frame in this case to, let's say 200 over 200. And then we could say, well, we got 3 of them we're going to display. Let's say each of them is going to be 50. So that should be about 150 should be enough. So we could just use that as 150. And then finally, I'm going to say frame.set visibility to true to display this. Well, of course, I need some stuff in here to be placed. So we will go ahead and bring in for this one, let's go ahead and bring in the frame init function, which we need. And the frame init function is going to allow us to nicely place the cells we need. So what are we going to do here for placing the cells? Well, let's go ahead and place the cell first of all. So to place a cell, what we could do is simply say iterate on I equal to 0 to size. And we can define the size in just a second. So we will define the size as a local variable for now. So here is the constant call size. Well, that's even better. And then we're going to have another array that we're going to define over here. So let's go ahead and do that. So that becomes the J values. Again, we will say size. And what are we going to do within this? We're going to go ahead and create a bunch of content.add, and we want to add a cell over here. So it's a new cell, and we're going to create a cell. What is the cell going to be? We'll call it as tic-tac-toe cell. How about that? And that's going to take the I and J as the value. So we are adding a cell. And of course, as we go through, we're going to do some work with the cell every time we click on it. But we need a cell to begin with. Let's go ahead and implement the cell. It's in the UI. And that takes a row and it takes a column value as a parameter. Let's go ahead and define a few things we need right now. I'm going to say row, and I'm also going to say a column. But notice I'm going to implement these two guys as final, so I don't have to worry about these two being modified along the way. So we will call this as the row, and we'll call this as the column. And I'm going to simply say row equals the row, and column is going to be the column that we create. Well, now that we have these two guys, we're going to extend this from a J button, because all we care about is just a button we are interested in. So that becomes a button value. But we also want to set the size of it. So we'll call set size on this. And we will tell the size is about a 50 and a 50 for the height and the width that we want to place these. So those are the three things we created. It's time for us to just play with this and make sure we got enough things going. So let's go ahead and try this out. So let's go ahead and run this little code. And here is, oh, wait a minute, there's one button. What happened to the other guys? Well, obviously we want them to be laid out nicely in a grid. So we could ask for a proper layout. So we could ask for a layout right here. So we could say set layout. And the layout we want is new, let's say grid layout. And the grid layout that we want could ask for a row and column. Well, we want 3 rows and 3 columns. Let's see where that takes us. Let's go ahead and run this now. Oh, there you go. We got a nice grid with all these columns available. Well, when we click on it, we want something to happen. So what do we want to do when we click on it? Well, we can go back to the cell and we can handle the click on the cell very easily, either within here or outside, depending on what we are trying to do. So when you click on a cell, what do you really want to do on the cell? We could register that here if you want to, or we could do that code here in the main. So let's actually do that in the frame itself. So in the frame, as we create a cell and register it, let's change this just a little bit. Let's go ahead and say this is going to be our cell, where our cell is going to be a local variable we are creating right here. And this is going to be our tic-tac-toe cell. So we will create a tic-tac-toe cell. And what is this going to be? Well, equal to new tic-tac-toe cell. Now that we have created a cell object, we can say cell dot, and we could say add mouse listener, or we could say add action listener. And the action listener will tell us that some kind of an activity happened on this. Well, where do I want to put the action listener? Well, let's go ahead and say new, and we will call this as, let's say, cell clicked handler. How about that? So the cell clicked handler is going to handle the cell click. Let's go ahead and implement that as an inner class right here. And that implements the method that's needed, which is action performed. And we got an action event. So we'll call this action event. Great. Now, what do we want to do with the action event when that's clicked? We can say action event dot get, and we can find out from this the source where it was clicked. And that's going to be the cell that we are getting back. So we could say that's the source. But this really is our tic-tac-toe cell that we are getting. And so I'm going to set that as the source or the cell that it was clicked on. So we'll just simply say cell for now. So now we know what cell was clicked on. Now what do we want to do? Well, when a cell is clicked on, we want to go ahead and set that into the tic-tac-toe board. Aha, we need the tic-tac-toe board at this time. So tic-tac-toe, so we'll say tic-tac-toe dot, and we're going to say the method to call the pressing of that particular or placing of that peg, isn't it? Well, obviously it makes it easier if we know what that is. So we will go ahead and create a field for tic-tac-toe, and the field is going to be what? Well, neither of those are going to be the field. So we need to ask him to bring in the other package. So let's make this a little bit easier on ourselves. Let's go to the class over here. And in the class, let's say we have a tic-tac-toe, and we'll say tic-tac-toe is the name of the field. And in the frame in it, we can say tic-tac-toe equals new tic-tac-toe. So now we can come back to this code and say tic-tac-toe dot place peg. But where do we place it? We place it on the cell dot row and cell dot column, right? That's where we're going to place this. Now that we placed a peg in that location, we want to change the cell to whatever that guy is returning. So peg placed equals, and now let's go ahead and say the cell dot set text is going to be, well, what do we want to place? Well, whatever the peg that we placed, we want to place it. Well, in our code, we could say if the placed peg is equal to peg dot, well, let's make it easy on ourselves by doing an import here. So let's go back here and say import game dot tic-tac-toe dot peg. That reduces the noise just a little bit. So now we can say is peg dot first. What do we do if it's peg dot first? Well, if it's peg dot first, then I'm going to place X. Otherwise, I'm going to say otherwise if it is the other one. So if placed is equal to peg dot second, I'm going to go ahead and place cell dot set text to O. But the beauty of this is at the UI level, you can pretty much decide whether it should be XO or something else entirely different. You can decide that based on placing an image, placing a different text, up to you. Well, one more thing we need to check. We're going to say if tic-tac-toe dot, and we're going to say winner is not equal to, let's say, peg dot none, then what do we want to do? Well, we could actually save this as a winner to play with it. So we could say winner, and what in the world is winner? It's a local variable, peg winner equals, and we're going to store that. If it is not, we can simply say something along the lines of option pane dot show message dialog, and we can say we have a winner, and then we could simply say something along the lines of the winner's peg. Well, again, we need to display what the winner is. Let's just say winner.toString here and see what that would show up as and display it. So, but of course, we need to tell what component that's part of. So let's go ahead and say that's going to be the cell, and that's going to be just displaying that particular content. It could be the frame, the cell, whatever that you want to show there as a default handler for that. Let's see if we got anywhere at all with this. Let's go ahead and run this code. There's the board that appears. Let's press on this one. Hey, that's a X. Let's press on this one. Hey, that's a O. Let's press over here. That's a X. Let's press over here. That becomes a O. Let's press over here. And we have the winner. And the winner is first. That's what it tells us. So you can see that the first player is the winner. Of course, if you really wanted to, you could modify this string and specify the same detail we specified here, and we can go with that. So that shows us how we wrote the UI. Now, there could be parts in the UI that could be moved to the lower level. You could write test on it, or you can write a UI level test. But remember the test pyramid we talked about, we want to keep these as little as possible as we go through. So let's talk about some lessons learned. We started applying tests, and some initial tests are defining the user interface, or the API rather, and how do these methods look. If you remember, we struggled with this quite a bit in the beginning. We talked about bringing players, we talked about bringing other things. So what did we end up with? Well, with all the classes we started with, we ended up with a class that implemented rule, and internally we had a collection of pegs. So this became an enum, this became the main object, and we have a GUI, and the rest of the stuff simply disappeared. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 things we considered, but we pretty much got this done with about 4 things. Of course, cell also was a class in the UI level, so we had 4 instead of these 11 things. Now, doesn't mean this is the right way to do. This is just one way to do, but design is just what we create based on what we think. But simplicity is very important. Minimalism is very important. Let the test give you this opportunity to debate and figure out what may make sense. So we also looked at some principles along the way and the practices. Remember, jot down the test cases as you are working on the code. When you think of more test cases, bring those test cases in as jotting them down and not immediately modifying the code. So quickly to summarize, the test-driven development is an act of design than an act of verification. We are driving this based on feedback that we get by writing the code and writing the test and making sure the tests are passing. It gives us sustainable development, and the tests serve as a documentation, and the tests serve as a safety net when it comes to refactoring. You saw that we were refactoring code a few times, and every time it gave us a feedback whether the code still worked or it was broken. And whenever you're adding a feature, you add the feature by writing the test. So evolve the test and evolve the code. So some of the tenets of test-driven development. Write or change code only if a test fails. If all the tests are passing, only refactor code, but don't add any new code. If you want to add new code, if you're not sure, hey, look, this code I have, but I need to write more code, well, write a test that forces you to write that code rather than just writing the code. You saw that happening in our example. We had a very little trivial code in place where we were simply setting the current peg and returning the previous peg. Then we wrote the next test, and that opened up and brought in the array of peg enums. So let a test drive the code you're writing. Write minimum code that works. Don't write any code. If you remove some code and the test will still pass, that was not minimum code. So keep the code very minimum. Seek a very pragmatic and simple design. The goal is not to create a grandiose design and show everybody how complicated things can be. The beauty is in simplicity. So create simple code and minimum code. You don't have to have a lot of stuff. You just need the essential stuff. And eliminate duplication both in test and in code along the way. We followed this red-green refactor. The test is failing, you make the test pass, and then you refactor the test to make it work. And follow this mantra, make it work and make it better real soon. Not in the next 7 months, but as soon as the code works, come back and refactor and see if you can make it better. Use this rule that untested code is unfinished code. So if you have not really finished a proper amount of testing on a piece of code, don't declare it's done. It is still work in progress and you're working on it. You can use the test as a safety net when it comes to refactoring. So when you are refactoring and improving your design or improving your code, the test immediately tell you that you're still okay, keep going. That gives us speed, that gives us confidence. It really helps us to know that we are on the right track. Not only test your code on a single platform, but test your code on multiple different platforms also. If your code is supposed to work on 7 different platforms, run the test in automated builds on these 7 platforms. It is really frustrating when the code fails on one platform 7 months after you go into production. You want that, remember the details we talked about. The time between writing code and finding the problem should be as short as possible. The more time it takes, the more expensive it becomes. So run your test on every single platform using continuous integration tools like Jenkins, Bamboo, TeamCity, Team Server Foundation, Cruise Control, name it, whatever tool you want to use the tool to do that. And don't forget functional test also at higher level. This example was small enough, we didn't have a need for it, but in any complicated application, we have test at different levels. For example, in a production system I got test at the domain level, I got test at the controller level and service level, and at the UI level. Who should write the unit test? Well, the unit test should be written by programmers as they are sitting down to write code, not by some other programmer at some other time. And keep in mind, you need to follow a nice rhythm. A little bit of test, a little bit of code, a little bit of test, a little bit of code, a little bit of test, a little bit of code. So this rhythm has to be followed. This is like walking on the beach. You don't let one of your feet walk for a mile before the other feet catches up. So if you put your right foot forward, then you put the next left foot forward. So a little bit at a time, march along, a little code after a little test fails, and then a little bit more code after the next test, and keep marching along the way. If a test passes without you having to write any code, then examine why the test is passing. Make sure the test is passing for the right reasons. And when should you write these unit tests? Like I said, when you're writing the code, marching along. Well, what about legacy code? Well, the very first thing I'll say about legacy code is put an end to legacy code by not writing more legacy code. Michael Feathers, in his book, Working Effectively with Legacy Code, talks about this. He says, legacy code is a code with no tests. You definitely want to write tests along the way. So if you have a legacy application, start writing tests for new code you're adding to legacy applications. If you're going to fix a bug or refactor or improve a design or make an enhancement, then write tests. Don't go on a witch hunt to write tests on legacy code, because we are not really connected with the code and we don't write good amount of good tests when we do that. Instead, write test on legacy code when you are ready to make an enhancement, fix a bug, and have that commitment and the discipline to write it at the time, but don't go off and start writing arbitrary test on legacy code. And like I said, the first thing we do to a legacy system is to put an end to legacy. So if we are very disciplined, dedicated, start writing tests for any new code we are writing, start refactoring those and write tests on it and integrate them. Then over a period of time, the legacy code doesn't grow into a bigger legacy code with no tests. We got parts that have tests and parts that don't, and over time, slowly that part begins to shrink, however slow that could be. So writing test case requires a certain amount of learning, but unlearning as well. As we talked about, you really use this as a design tool. While the regression benefit is definitely there, the design benefit is enormous if we are conscious and careful and aware when we are writing these test cases. So as you're writing these test cases, ask yourselves, how could I make these test cases better? How could I make these test cases influence the design? While you're writing the test, if you're not really debating about these design concepts, you are using the test as a poor vehicle to just, follow a mandate, but not using the test to really drive your design. When you drive your design through test cases, the shape of the code you create will be very different from the shape of the code you create without the design. And there is enormous benefit to using these test cases to drive the design of the application. Try out some examples. Ask a colleague or a peer to review the code you write, and based on their feedback, go improve the design of your code. It's a lot of fun. It's a great learning experience, and I hope you get to enjoy that as well.